Okay, so today we're going to be talking about connecting the dots using backwards design to create cohesive health sciences instruction. And for our speakers today, we have three dudes. We've got Sean Koebley, he was a middle school math teacher. Okay, Stephen, Wechman, and Jonathan Lindsay. All three have PhDs. Sean is from William & Mary. Stephen's from the University of Louisville. Jonathan's from the University of Tennessee. They are all here as postdocs as part of the ERACTA program, which is an institutional grant that's geared towards research and teaching instruction. So they are learning how to be great instructors, as well as doing postdoctoral research for their career goals. Okay? So they're here to talk to you about this. Okay? You will need paper and pen. We've been talking about that, so everybody should have it. Again, water and cookies. If you need anything else, just ask the dudes, okay?
All right. Well, thanks for the introduction, Stacy. Hello, everybody. My name is Sean, and as Stacy said, I'm part of the ERACTA program, and I, as well as my colleagues today, are going to be talking about one of the most important, kind of exciting techniques that we have really talked about a lot in our program, and that we just learned about during our summer institute that we attended on the West Coast for a week, where we got a lot of intensive training on how to teach. So we borrowed a lot from that summer institute presentation today. That was with the Howard Hughes Medical Institute, and there's a lot of information on the things we're going to be talking about today, both in our slides and on the Howard Hughes Medical Institute website, and a lot of other places. What we're going to be talking about today, which is backwards design, is not a new concept, but it's one that I think comes up over and over again when we think about what really makes effective instruction. There's a lot of things that go well if you backwards design your classrooms. So that's what we're hoping to convince you of today, and maybe get some practice doing. We're going to be doing some this today as well. So with that in mind, we're going to start off with an activity. We want you all to think about how you would plan a certain lesson, and this lesson would be the process of riding a bike. So we don't want you to necessarily list out the steps of how you learned how to ride a bike. Maybe that would be helpful. But what we want you to do is think about how you would teach this. Say you have about an hour, or maybe even if you want to get ambitious, you could do a week-long curriculum. But we want you to think about how you would teach someone how to ride a bike. So we'll give you about 3 minutes to do this on your own. This is what your sheet of paper is for. And then we're going to compare with each other and then share as a class. Okay, let's take about another minute. It doesn't have to be the fully fleshed out plan, just looking for a skeleton. Okay, well, no matter where you are right now, I want you to turn to someone next to you or nearby and talk about what you got. Compare and contrast what your plans look like. All right, everybody, let's bring it back.
Thanks, Sean. So I heard a lot of really great ideas. A lot of it was emphasized on helmets. I heard it from at least 3 different people, which was interesting. But I also heard a lot of activities based on what you experience as children, and trying to relate that forward to how you would do it for someone else. And certainly when we're designing learning activities and lesson plans, building on what we know and what we're familiar with is very, very effective. But part of what we're going to try and do today is try and formalize some of your understandings, to really build it together and how we can build not just lessons we understand and lessons we think will work, but ones which seem to be more effective. And so one of the concepts that we want to focus on is recognizing where there's a disconnect. And there is a difference in teaching somebody how to do something by doing it, and designing an effective lesson so that at each point we have this logical progression. And that throughout the process, everything is building till we get to that ultimate objective, which in this case is riding a bike. And as we all just experienced, there's a lot of steps to it. And so what we're going to do today is, right now, we're sort of going to explicitly state, we're going to talk about backwards design. And all of you will be able to, by the end of this course, to identify the motivation and goals of backwards design, to define and order the components of backwards design, which is extremely important, and use backwards design to help craft your lessons. We really want you to be able to take some concepts we discuss and reapply them to yourself, particularly if you've taught it before, so then you can kind of reverse your thinking and perhaps reveal new ways to discuss your content. So backwards design, here shown in the simplest way possible, is a 3-step process. And there's a lot of text here in each of these steps, and some of them are kind of vague. But what this really is the 3-step process of number 1, identifying your goals, the concepts that are most important to you, and more specifically, those learning objectives. What is the one thing you really want them to be able to do and want them to know? And 2, acceptable evidence. Acceptable evidence in the classroom, that's how you as an instructor can certify that this person knows it. This is like exam grades. And we're going to talk about some other ways to assess later on. And then 3, this is the lesson. The lesson comes last. After you've fully understood your goals, your broad goals, your objectives, which are more specific, and then how you're going to test them, that tells you how you need to teach them. Because by considering all this alignment, everything should be in harmony. You know, you ever had those students who they don't understand what they should study, but they're confused when something shows up on an exam? Well, maybe that's a result of, maybe not intentional, but a misalignment from what you intended, your high-level goals, to what you ultimately tested, and then how you designed the lesson that they were learning. And so now we're going to take a more detailed look. So first we're going to show you the student's perspective. So order of student achievement, this is the order they're introducing and interacting with these elements. So first we have the lesson, or activity. But it can take many forms, and this is just what the students do. Building upon that are a couple of assessments, but first we have formative. So a formative assessment should be however it is that you assess that are students understanding. It's typically something a little bit more specific, like maybe a particular concept or terminology, anything. But you want to assess, are they forming an understanding from this? And this is how students will monitor learning. Because as instructors, we should be both teaching them well as monitoring them, so they seem like they have a deficit or something is wrong, we can help bring them along. Now, summative assessment. The term here is crucial. Summative means it's now more general, and we're bringing everything together. Summative assessments tend to be very highly graded. These are maybe your biggest exams. Formative assessments may not be graded. These may take the form of a short answer, non-graded, even just a conversation. So your summative assessments are how they're going to demonstrate it. Learning outcomes. So these are what the students will be able to do. This is the result that we're going for, that we want them all to achieve, and then this is them going through the process, and then of course the learning goals. But this is backwards. So if you're the instructor, you want to make sure you lay out clear learning goals, which are very general, going through specific outcomes for even each lesson. Then you develop your exams, and last your lessons. And these are your smaller assessments. So this is kind of backwards the way we typically think about it. That's why it's called backwards design. Because I don't know about you, but in the past, I've typically made a lecture first, and then said, how can I make questions on it? But if you have the questions first and some of these other ideas, you can really go through very coherently.
So the first two components of backwards design are the learning goals and the outcomes. The goals are the very first step. This is the first thing that you begin when you do this process. The goals are typically overarching themes of your class. They are going to be on your syllabus, and there's going to be 5 to 10 different goals typically listed. These, again, are the broad concepts that you want your students to come away with from your class. And then with outcomes, you're simply breaking down your goals into specific skills that you want your students to be able to perform. So per goal, you'll have about 3 to 5 outcomes. So what is the main difference between these two components? Goals are broad and vague and not easily measurable. Again, they represent concepts or ideas. When you're using words to describe a goal, you use words like understand, know, and appreciate. An outcome, however, is very specific. It's concrete, it's measurable. It's a particular task that you want your student to perform. When you're using verbs for this component, you will use words like predict, contrast, describe, defend. And these words are extremely important, especially how it pertains to student assessment. So the words that you use for outcomes can be very specific to what level of understanding you want your students to walk away with or to be able to demonstrate. Okay? So let's look back at learning goals. Again, this is the very first step of the process. When you write down what a learning goal is, or what your learning goal is going to be, you start with students will understand, students will know, students will appreciate. So for a learning goal on a lesson for DNA replication, you would use something like students will understand the process of DNA replication. For photosynthesis, students will know the process of photosynthesis. For something like molarity, students will appreciate the importance of molarity. So let's go ahead and do a quick formative assessment. So, can someone tell me what a learning goal is for our riding our bike activity? So, very simply, what the goal is for riding a bike. Out of hand. Julie.
Learn how to ride a bike.
Learn how to ride a bike. Students will learn how to ride a bike. Yes, that was a very difficult assessment, but I'm glad you got
Thanks for trusting me with that.
You're welcome.
I think the point with goals is that they should be a little easier to kind of like conceptualize. These are the big ideas from your class, your lesson that you really want the students to get. They're not easily measurable. That's the thing about goals. Like, how do you know that students will know how to learn? How do you know they know how to ride a bike? You know, there's a lot of things that go into that. So this is your starting point. I think it's important to think about what your major goals are for a class, and this is probably what a lot of us do intuitively when we're designing a class or a lesson, is thinking, what in an ideal world, what do we want our students to know, and like from a more deep fundamental process when they come away.
Right. Yeah. And so from this, as you're trying to formulate ways to be able to determine if your students are getting this goal, you want to write outcomes. So you write many specific outcomes that you want your students to be able to demonstrate from that goal. So when you're writing an outcome, you start with students will be able to. And so we'll look at our examples again. Students will be able to identify the different photosystems and the roles in photosynthesis, something like that. Students will be able to create an accurate diagram of DNA replication. Students will be able to critique the arguments for and against the theory of evolution. Does anybody notice something with these examples? Well, I would just say this. Notice that there are different levels of understanding here. Being able to identify different steps of something is very low level order of thinking, whereas critiquing and making an argument is much more higher order. You want to use both lower and higher order levels of thinking when you are trying to assess your students. So make sure you're using multiple ways of assessing the level of understanding of your learning goals through your outcomes. Okay, so I will get more into that here in the next slide.
Yeah, I might just point out the difference again between this and goals. These outcomes are measurable. These are things that you can actually, that they're much more easy. They're easier to maybe write a test question for.
Right.
That's what you should be thinking about. And I saw a lot of this when you guys were doing your riding a bike exercise. You seem to be breaking down that larger goal of riding a bike into steps that you would need to take in order to get to that goal. That's what the outcomes are. They're breaking down your goal into steps that are measurable.
Okay, so let's go ahead and write down some outcomes. for our bike. Okay. So, does anybody have an outcome that they may have been able to get from their students who learn how to ride a bike? Yes?
List the safety measures one can take.
Well,
Oh.
that's an interesting outcome because that actually is deviating a little bit from what our overall goal is. So listing something like safety doesn't necessarily show that they're able to ride a bike, right? So that is deviating a little bit from the alignment of measuring or being able to assess a particular outcome. So maybe another one.
Identify the features of a bicycle.
Okay.
Like the brakes and the pedal and the seat. And
That might help with understanding and showing that they're able to ride a bike. Something that I was thinking of was demonstrating that your student can pedal your bike properly. Something like that, pedaling. What's another one?
Stopping.
brakes.
Stopping, braking. Right, that is a very important concept of being able to ride a bike. What else? Something that I thought is important too is steering. Steering is a key component of understanding how to ride a bike. So again, these are things that are accessible. They're also demonstrating an ability to do something that relates to what your overall goal is. Okay. All right. So, as I mentioned, the verbs that you use are pretty key in terms of being able to assess levels of understanding or levels of knowledge that are brought out in your outcomes. So this is Bloom's taxonomy. It is a hierarchy and mastery of concepts. So, and this lower order level of
The pointers don't work.
Yeah.
on
Yeah.
this kind of
Yeah.
board.
I just point with my two. So at the lowest level, you have things like remembering. So when you're forming your sentence for your outcome, you would use verbs like identify, describe, memorize. Moving up, understanding, explain, infer, paraphrase, applying, draw, apply, solve. And then the higher levels, you use verbs like critique, test, build, construct, categorize. Things of this nature. Okay. Awesome.
Why are the top three lined together? Usually when you see Bloom's, it's a hierarchy.
Yeah, good question. I think this is actually based on a recent paper that was trying to do maybe a meta-organization of these and think about how, well, is there really, I don't know which one of these was on top, whether it was analyzing or evaluating. I think the thinking was that, well, those are all higher order skills here. It was more of an organization of higher order at the top and then lower order at the bottom. That was maybe the more significant way to organize these skills. This is probably very familiar to a lot of people. This has been around for a long time. I think there's actually some varying degrees of thinking of to how useful or how precise you have to be with those categorizations. I think that's where this kind of diagram comes from. But I think the foundation, what we're trying to get across is that the verbs you're using when you're making your outcomes are very important. It's an extremely useful tool is to actually pay attention to those verbs when you're making these outcomes. If you're asking students to only even explain or infer, it's still kind of regurgitating information. You may not be able to assess, or when students assess those, you may not get to those higher level thinking skills as much as you might think you might be. If you're rather asking them to judge or categorize or produce, then you're really accessing a completely different set of knowledge, and the students are going to be able to do perhaps those higher level thinking skills. Maybe you only want them to do lower order thinking, and that's fine for some activities. In fact, you have to get to the lower order first before you can build up to the higher order. But it's just being very intentional with how you use your verbs. That's what I think is maybe missed a lot when people are designing lessons. I know I find it hard to break away from identify and discuss and explain. Those are really useful verbs to use, but it's harder to get up into the higher order level. ones as well. So once we're going backwards as we talked about. So once you've kind of defined your major goals and you've broken down those goals into outcomes, then it comes time to determine how you're going to actually measure if your students know they can do these goals. How do you know if your students have actually achieved the outcomes and ultimately the goal that you want them to achieve? So to do that, and we're going to do a little activity. I want you all to take maybe just 30 seconds to read the following paragraph. It's going to be a quiz, too. So.
Did Dr. Seuss write this?
Okay, now that you're all experts, here we go. Here's our quiz, or here's our test. Not just a quiz, a test. This is a summative assessment you might give on a paragraph like this. What is traxoline? Who can tell me?
You can just shout it out.
Sure, shout it out. A new form of Zienter. Perfect, 100%. Where is it montillated? What, montil? Yeah, montil. Where is it montil? Yeah, Suristana. Perfect. How is traxoline quaseled? Right. Yeah. And why is it important? Well, we'll see. Maybe it has the potential to make the most useful product.
Everyone knows why.
Oh, right. Yeah. We don't have to go over this. Yeah. So this. What kind of questions would you say these? Or what order? What level of understanding might these questions be? Yeah, these are lower order. These are lower order questions, and I think maybe the point of this exercise is that if you get in a freshman biology class, the first time somebody's reading a paragraph in a freshman biology text, this might be what it looks like to them. They might be seeing something that is, completely bizarre. A lot of words they don't know, and the questions that you're using to measure their understanding, they may be getting these questions right. It may not actually be getting them to any realm of understanding of what's going on. So, what we're going to talk about today is how, I think one of the things to think about is getting beyond those lower order questions allows you to help students synthesize the material, really understand what's going on, connect a lot of different concepts, basically do the things that we want them to do in order to learn and achieve those major learning goals. So again, that's going back to Bloom's taxonomy. You want to start with those lower goals. You may want to start with these questions, but then build on those to do more, so they actually understand what traxoline is. Which, yeah, we won't get to that later, but that'll be extra credit. So, to kind of give an example of how this process might work so far, you start with a learning goal. What will students learn? In this case, the example might be understanding the transfer of information from DNA to proteins, starting on the left here. And then you might break those down into several learning outcomes, like what will they know and able to do? Able to predict changes in amino acid sequences caused by mutations. That might be a little getting up to a higher level order scale once you understand what a lot of these terms are. You would learn to be able to predict those changes. And then they'll have to, the assessment for this specific outcome would be how do they demonstrate this outcome? They'll actually do it. They'll be able to predict the amino acid sequence that results from mutation. So you would write a test question based on that specific outcome. Okay. I have to say, this step of making summative assessments, making your test questions before you even plan a lesson, is probably the most difficult part. That's probably something that I think not a lot of us would think of. Because in reality, what that means is you have every single test question, maybe major test question, written before the first day of your class. And that's kind of a daunting challenge. And we'll talk a little bit later about how to do this in reality. And I think that's probably something that not a lot of teachers are doing, even in teachers who are well familiar with this technique. But I would really encourage you to try this out. And I'll say I'm going to be trying this out in my classes. We did some of this when I was teaching middle school. But I think it's a really powerful thing to actually have your test questions in mind when you're planning your lessons. That's an extremely powerful use that makes sure that what you're doing in your lessons are actually aligned with these test questions. So after I would say these are the most important parts. Then you actually start designing your lessons, which is, identify reading frames, template coding strands, sequencing, predicting amino acid changes, all the things you need to do to get them to answer that single test question. Okay. So let's do it with our example that we did at the beginning of the class. Once we've identified our major goal, a few outcomes here. Let's some ideas. What would a test question look like, a summative assessment look like, for IDing the features of a bike?
You have a diagram to make the label?
Yep. You can have a...
There's lots of colors.
Put it back in the tray.
Yeah, here, we'll use a better color.
Such a tricky.
Label a diagram of a bike. That's perfect. Anybody else? How about demonstrate proper pedaling? Might be a good summative assessment for that.
Have a stationary bike and get them on the bike.
Ah, I love it. I love it.
That's for braking.
Oh,
okay, yeah.
Okay, yeah, how about braking? This one's a little trickier. This might be a higher order.
Put them at the top of a very tall hill.
Oh, yeah, push them down really fast. Yeah, I like that. I don't cover steering too much.
Zero safety, however, on that one.
Right. I know, I kind of disagree with Jonathan about whether safety is a part of riding a bike.
Well, it's a goal to make
Our
it
goal
safe
would
to
be
ride a bike.
Right, there you go. That's great. You can adjust your goal, how to save your bike.
Could you just put all those together and create like a test course that they have to, achieve?
Okay.
Go
What would the
through some
assessment look
codes.
like?
They would have to
Oh,
go
they'd
through
have
the
to-
correct
Like a
route,
driver's
like
Perfect.
a driver's go
Yeah.
through some
Oh, I
codes,
love that.
Stop
Yeah.
at these stop signs.
Yeah, I'd say this would be kind of,
Comprehensive.
Yes.
Yeah.
I think maybe that could be even another outcome, which would be, actually riding a bike. Ride a bike independently, maybe, right? Because I know about you guys, we had training wheels beforehand, and they could actually ride an obstacle course. That's a fantastic summative assessment. Yeah, braking, steering, you might have something like training wheels or be holding them as they're biking. These are things you could use to kind of assess those independent outcomes, or maybe that, depending on once those prior outcomes have been achieved, then you could let them, assess those other outcomes. So the point here, though, is that you think of these first before you actually think about what you're going to do with them. I think it informs the activities you're going to do to actually to bike with them. But I think the important thing is that once you get this map, it becomes much easier to define and design those activities. Oh, no. Very nice. Okay, so those are kind of our test questions, our summative assessments. That's what we're working towards. Then you get to the task of actually designing your activities and your formative assessments, which again are like ungraded assessments that you're doing, extremely important. They're assessments that are being enacted during the class. And there's a very clear difference between those two that we're going to get to. So to get to that, I want you all to think about, how do you know something? Okay. How do you know when you know something? How do you know when your students know something? Then how do your students know when they know something?
How do they know that they're right?
So take 30 seconds for you to think about it. A little less than 30 seconds. You can write something down too if you have any answers to these. Okay, I want you to share with a neighbor what you think. These are great questions.
How do you know explain or apply?
How do we know?
Okay, so we had some great discussion. Let's bring it back. I'm wondering what is one. So which we've got kind of three different concepts here. Which one do you think is easiest to know? Which one do you think is easiest?
The first one.
The first one, yeah. I mean, you'd think that'd be easy. Sometimes you don't know if you know
I
something.
think that's the hardest.
Huh?
I think that's actually harder than knowing that someone else knows what you want them to know.
Yeah. Yeah, so I mean, sometimes that second one, do you know what your students want to know?
Yeah.
If you have a very clear idea in mind, if your summative assessment is very clearly matched to your outcome, then that one can be pretty easy sometimes. It's like, well, I want them to be able to know how to pedal a bike, and they are doing it by pedaling on the stationary bike, so that one's pretty easy. How about that last one? Any ideas on that last one? So an easy or tough?
I think they depend on the grade.
Yeah, grades are one of the, maybe only ways that they get feedback on whether they know something. Are there any other ways that students, how do they know when they know something?
I tell my students that if you can come to my office and teach me the information, then you can be confident that you know it to some basic level that you need to for the test. But
That's a really important message.
But many of them just don't do that. So.
Yeah.
We were discussing think, pair, share for the last one. So if you can explain it to a student that has lots of questions, so explaining it to an instructor is great, but the instructors know the information, so they often don't know the questions to ask. But if they can explain it to a student that doesn't know the information, they'll ask questions, and if they can answer those questions, then they'll feel confident that they actually know the material.
Yeah. Those are great ways that students are getting instant feedback and are able to show that they actually know something.
There is a danger at that, though. If the,
sure.
If the students are both misinformed, then they are both misinformed,
Sure.
and they will enforce that misinformation. So as a teacher, I have to be back to what you said. I have to be cognizant of what the student is telling me, and act like I don't know what the hell you're talking about. What? Like it's real easy to do that after you drill for a long time because you know exactly what the students look like and the question and where they stumble. So the longer you do it, you know exactly where, okay, this is where, and you can tell them ahead of time, this is where people have a hard time, so let's follow this. And you get, in theory, you get better at anticipating the problem areas.
Sure.
So
I will point out, too, we've done a couple think, pair, shares in this seminar already, and one way to kind of make sure that everybody's more on the same page is bringing it back to the whole class afterwards, and maybe, listening to what the students are saying and trying to reinforce whether or not there's some misconceptions and talking about those and aligning all the students to the same path. That's one way to do it. There's also other ways to let the students, to give them instant feedback during class. I've definitely seen a lot of that at VCU classes. Has anybody else seen that? Another way that students get instant feedback?
Like poll everywhere.
What?
Like poll everywhere.
Yeah, poll everywhere. Clicker questions are a great way to do that. Yeah.
Sorry, what is that? It's like clicker questions.
Oh, okay. Like we used to do like head backward, like the baseball cap thing. Like
There's so many ways to do it. We're going to try another one later in class that I think is one of the easiest ways to do it. But yeah, I would say even just thinking about these questions in your classes and when you're designing your tests and your assessments during class, your formative assessments, is already putting you maybe a little step above what I think is typical for a lot of college classes, is actually thinking of what are the students doing to show that they know something. Are they going to do this during class or not just in an exam? Ideally, the students, you're going to be getting feedback, every class on whether the students are actually understanding what you're teaching them. That's not something that I think is a given for a lot of teachers at any level, I would say. They may be thinking, all right, the one time they're going to get feedback is the exam, and that'll be enough. Maybe it's halfway through the semester. Yeah. And I just want to, this is a quote from a paper that's I think is a really important one, that ongoing assessment plays a key role, probably the most important role, possibly the most important role, in shaping classroom standards and increasing learning gains. That's something that I like, that act of self-assessment, peer assessment, and assessment from the teacher is just so important. And I'd say that the way to do this, one of the great ways to do this is to actually have students do something. Because when they're doing it, they're engaged in learning, they're actually trying out the things that you're teaching them, and they're able to self-assess. It's two parts to that. They're able to gauge whether or not they're achieving the goals that you're putting out in front of them. I love this question. So we're gonna demonstrate some of these ideas by using this question. I want you all to take a look at this. I know it's a little tough to read with the font, but take a look, and I want you to, on your own, come up with an answer, A through E, and write it down, and then we're gonna talk about it. Take about 5 to 10 more seconds if you ever already written down an answer. Yeah. Okay, I want everyone to close their eyes and raise your hands if you think, I'm going to go through I'm going to go through A through E, and I want you to raise your hand if you think that's the answer, okay? Everybody, eyes closed. If you think it's A, raise your hand. If you think it's B, raise your hand. If you think it's C, raise your hand. If you think it's D, raise your hand. If you think it's E, raise your hand. Okay, everybody hands down? Nice, that's interesting. Sometime, by the way, that's one way to kind of to do a self-assess or an assessment of how it's kind of an alternative to a clicker that's a little easier and faster. It just gives the teacher an idea. What we can do now is do this with eyes open. So I kind of have an idea of who said what. With eyes open, if you said A, raise your hand. If you said B, raise your hand. If you said C, raise your hand. If you said D, raise your hand. If you said E, raise your hand. Nice. So we have a pretty even distribution. What I want you guys to do is talk to someone else, preferably someone who maybe got a different answer than you, and see if you can reconcile what the difference is.
What did you say? I said D.
Okay, bring everybody back. Let's do this one more time.
Sorry, again, that's what I said.
All right, if you think it's A, raise your hand. If you think it's B, raise your hand. Ooh, more B's. If you think it's C, raise your hand. Ooh, more C's. If you think it's D, raise your hand. If you think it's E, raise your hand. Still some E's. Okay. Well, I think we're running a little short on time. I'm going to make sure to get our last activity. But I think I love this activity for just kind of seeing how the answers change and how people talk about this, how they try to talk about this problem. This is not an easy problem. I'll say there's a lot of biological scientists, including myself, who got this wrong initially. Does someone want to try to explain why they answered the way they did? Yes?
I've got an answer. So I'm not a scientist, but I took biology in college. My assumption is that dry weight means that you would remove all water.
Exactly.
So there absolutely no water. My assumption is any growth at all would have yielded more cells grown, and even though they would mostly be made of water, there would still be like cellulose in the wall. So like there would be a tiny bit more stuff.
Where would that mass come from? If they're gaining mass, where would it come from?
Photosynthesis. Thank you.
Photosynthesis. Yeah. Where does that actually? Where does the mass come from, though? Does anybody know? Where does that extra mass come from?
Carbon dioxide.
Carbon dioxide, right? It's coming from the air. So that carbon that's being added to it is coming from the air. That's good. So you're saying that it's 2 is greater than 1.
B. Yeah.
You're saying B. 2 is greater than 3, which is greater than 1. Does anybody have an alternative answer to that, or something? Some way that like to argue. I didn't see a whole lot of B's.
It's D.
Well,
it's going to be D. It's got to be D. Two is photosynthesizing, so you're fixing carbon.
And that's the only one.
And that's the only one that's gaining mass. 3 is actually going to be less than a dry weight of 1 because 3 is also undergoing cellular respiration, so it's burning sugar. Therefore, it's going to ultimately be lighter than the dry weight of the number 1 because that hasn't done anything metabolically. So it's 2. Yeah. Yeah.
Yes. Right. Yeah, so glycolysis is the act of burning sugar that doesn't require light. That's something that can happen. So there's a lot of levels. It's a deceptively complex problem. There's a lot of levels to understanding there.
Yeah.
And it's a great one because you can show the students right afterwards, you know, the evidence of what the answer actually is. It's fascinating. Yes.
So why did you do the eyes closed and eyes open separately?
Yeah, good question. So when you do the eyes closed, so one way, there's many ways to gauge the answers to these type of problems. One would be a clicker question. That would be anonymous if people are all submitting to an online service. One way would be if you have different colored pieces of paper, you could have the students hold them up all at once. That's a nice way of doing it because you get a very visual representation of what's going on, and if you're doing it all at once, there's less like angst about giving an answer that's different from everybody else. I think that's what the eyes closed can do. I think there's a lot of peer pressure that goes into answering the way other people are answering. If you're getting an answer that's wrong, you might feel self-conscious about saying something that's not correct. So you can do it eyes closed instead of eyes open. I like, the eyes closed one's interesting because it doesn't take, it's very light. There's nothing that you need to do to prepare for that, except maybe set some expectations about, how to close your eyes and do something in class. I don't know, the college students if they need that, but middle schoolers definitely would. The point is there's a lot of different ways to gauge what the answers are, and in all of those instances, you're letting the students get feedback on their own answers. You're giving them the chance to discuss the answer afterwards, and the professor is getting a sense of how they're going to do on an exam question like this. So you're getting multiple levels of this. How do you know? That is extremely valuable. You can see the learning experience is very different than I would have if I would have just put up the slide and asked you to explain the answer. Even that would be, I think, more maybe than a lot of classes do. In a lot of classes, they might just put up the answer and say, this is why, with a lot of talking to students. If you get the students engaged, if you get them to think about it with interesting problems, it really changes the learning experience. So with that, last thing we want to say before we get you into your final activity, your summative assessment for this seminar, is to just say that this is an iterative process. I would say that it's very valuable to start with your goals and then break those down into outcomes, write a test question for every outcome, and then design your lessons after that. Again, as I mentioned when I was talking about summative assessments, that can be really tough to do, to make a test question. All your test questions for your class at the very beginning of the semester, and it might change based on how the semester goes. You might be changing some of this as it goes to make sure that everything's aligned. But I would say that just that act of starting with your goals, going to outcomes, and assessments, and then formative assessments and activities changes the way that you design a class, changes the way you think about the material. So with that, we're going to do our summative assessment. We have about 8 minutes for this. We want you to break up into 1, 2, 3, 4, 5 teams of maybe 5, 4 or 5? Yeah, 3 or 4? So let's do 3 or 4. We got 5 posters up on the wall. We want you to do this. Oh, before we get started, let me make sure I explain everything here. We want you to work with a group to actually do this, to design a lesson from starting. And I'll open up the slides so we kind of have a review of how to do this. We're going to start with a goal. Oh, didn't spread it. Before we get started, thanks. Our goal here is to make the perfect peanut butter and jelly sandwich. That's our goal for this lesson that you're designing. We're going to use the process of backwards design to identify the goal, the outcomes, the summative assessments, formative assessments, and activities in that order. And you're going to write, once you kind of have those worked out, you're going to write them down in a sticky note. Okay? Afterwards, we'll have the groups, you guys can walk around, see what other groups have done, and maybe give some feedback and talk to each other. So we've got about 7 minutes for this. I'm going to say the first 2 to 3 minutes, I would recommend you maybe just work with the group at the table, write things down on your piece of paper, and then after that, start going up and writing on the Post-it note. So we'll keep you up to date. We're circulating if you have any questions. Go ahead.
Groups. All right, you got
have a paper? Here, orange.
Pink.
And you two want orange?
We'll work with that. Okay, everybody, I'm seeing some great stuff, but unfortunately we are about out of time. So what I encourage you to do is maybe on your way out, take a look at what the other groups wrote, and I'm seeing some good stuff here. I also want you to think about how, I mean, this is another activity that you could do in class. We've kind of modeled a few of those today. The different ways that you can have students formatively assess one another, either by talking to each other, this is called a gallery walk, where they're writing something up and then able to circulate and see what other people have done, maybe give feedback, maybe they'd be able to write on other people's post-it notes to edit or give comments on what other people have done. Clicker questions are a classic. There's a lot of different ways to do it to let students give feedback. But again, the main takeaway I'm hoping that we can introduce you to today, or maybe it's introduced, but it's something that we can give a reminder to, is that when you start from the end in mind, and you get your activities and your assessments aligned with what you actually want your students to learn, and it's much more likely that they're actually going to learn it. So with that, if you have any other questions, again, we're right out of time, but we can answer questions now. I think there's also an assessment for us at the end of this class, which is also very important. And yeah, thank you so much for your attention. You're a great group.